So far, we have covered laptop to build Hyper-V test. We talked about the overall architecture and the concept, what we are trying to do. Then we covered multi-subnet always-on failover clustering. I covered 6 different scenarios, how the end product of this whole tutorial will look like. So once you are done with playing this tutorial, then you'll be able to do it yourself, and you'll see that in which scenarios in a multi-subnet cluster you need to perform a manual step versus where it's automatically failover, as well as where you know that there is a problem and you have to take some extra steps to do the failovers. Okay. Then in the next one, we talked about the scripts and download folders, which all files we need to download. So we download Windows 2019 Evaluation Edition. We downloaded SQL Server 2019 Evaluation Edition as well as SSMS in that. Then we set up an existing laptop with a new VHD where we can boot with Windows 10 Evaluation Edition to do this, set up this test lab. And after that, we configured a Hyper-V, and then we configured a parent virtual hard disk with Windows Server 2019, which we'll be using to create all the next VMs so that our VM sizes are very small, so we can somehow squeeze into 128 GB of space to do all these VMs, 6 VMs in particular. In the last video, we realized that the space is a little bit less, so now the configuration will be 150 GB of space. And for this demo, since the drive size was limited, what we did is we moved the app VM into another directory and just changed the configuration. In the last video, you can see how it's done, and that way you'll be able to manage with the space we have. Then we configured a virtual router so that even though our networks are private, they can still access the internet without making much changes. By default, Hyper-V do not support it properly, and there are issues with that. With this virtual router, it will become super easy for any of the network to connect. And after that, we configure a domain controller. And once we are done that, we are ready to set up always on. So we created 4 VMs, 3 database VMs, and 1 app VM. And then after that, we installed SQL Server 2019. And the last video, we installed Windows Server 2019 cluster. So let's get going with our final setup. But before we do, I'd like to introduce myself. My name is Prakash Heda. I'm MSc MCDBA and MCATP. I work as a senior manager IT in SS&C Technologies, and I also run a consultancy firm. You can connect me on SQLfeatures.com to see the complete video series, or on YouTube. Plus, connect me on LinkedIn as well as Twitter if you have any questions regarding this video. So let's get going with the demo. So for this demo, what we'll be doing is we'll be setting pre-always-on steps. So before we configure always-on, there are some things we need to do. So let's start our PowerShell scripts. Open. Let's go to the part 12. So you can see there is an enable always-on script is there, and then there is a post always-on configuration there. In between, I'll be using GUI to configure always-on. We need to run some steps. So pre-always-on steps. So let's go through them quickly. First, as usual, we'll be connecting to the VMs. Then we'll be setting up enabling always-on on the node. So what it means is that we'll be checking what is the current version as well as if always-on is enabled or not. And as you can see, that is HDR enabled is the property which allows you to see if always-on is enabled or not. And then we are running command enable SQL always on. This will enable SQL always on. After that, we need to restart the services. So we'll do that so that changes in effect, and then we'll again validate if always on is configured or not. So let's start with the first step. Let's connect to DB3. As usual, you should be seeing DB3 here. So you're good. Let's validate. And we can see DB3 is running SQL 2019 with CU8. As well as version is 15.04.0.7.3 Enterprise Evaluation Edition. That's what we are running, and it says HDR is enabled is 0. So it's false. So we want to enable it to configure always on. So we run that command. Okay, so at this point always on is 11. So we need to restart the services. These 2 commands will restart SQL servers as well as the agent. So once this is done, we'll run the command to validate if always on is enabled or not. So the command is completed. Let's go ahead and run it. And now you can see is HDR enabled is 1. So at this point, basic stuff is done. So this part of the code we need to run for each of the VM, but rest of the code for the node 1, we have some extra step which we'll cover. We are done with DB3, so let's connect to DB2 and I'm run exit, so we get out of the DB3 we have here. We can run exit here or run this part. So we are now on DB2, so we're back. So let's connect to DB2. Now we are on DB2. We want to run the same command. I'm going to select this and execute it. Is HDR enabled is 0. And once these command executed, we should be able to see if the value is changed to 1. Came back, we can see HDR value is 1. So now let's exit DB2, and as we said, DB1 will be running these commands plus some extra steps, because that's the server where we want to we will be configuring AlwaysON from. Let's connect. So node 1 is connected. Execute this command. And as we can see, HDR is enabled. So at this point, all the 3 nodes are capable of configuring AlwaysON. So now we'll be creating 2 different variables. So one for AlwaysON share. So we're creating a file drive, C AlwaysON share. That's where the files will be shared, which means we want to create this folder, give it a shared name, and then have all the 3 nodes able to access it. So let's populate them. And the next command here, we are checking which is the service account for SQL Server. Let's see that. We populated the server name variable. And if you want, I can run it and I can see SQL Server services running with HV admin. So that's good. I'm populating that name into a variable, and now this account has our services startup account name. Now, the folder we created, let's go ahead and create that folder. So we created our test share folder. Now we want to share that folder. So this is the command we want to run: net share AlwaysON share, C AlwaysON share, and grant these SQL Server admin, which we just extracted, which service is running. So this service should have full access and we'll be running it. So first, let's check what is in the net share. We can see existing connection is there. There is no connection for AlwaysON. There is one for file stream, which is good as part of SQL installation. Now we run this command. This will create the share, and we can validate our share is being created. And we can see AlwaysON share is there with C AlwaysON share pointing to. Since we grant access to our startup account, all the 3 nodes will be able to access this folder, and that way the backups AlwaysON will work. Now let's create a DB name, like VM name plus test DB, and then this is the database we will configure for AlwaysON testing. And I'm going to run a command, and this command will just create the database. Since I'm on DB1, invoke SQL CMD will work just fine. Now, after we created the database, we want to back it up. Without the backup, AlwaysON will not work. Let me show you. So if I connect to, I want to configure it from the app server, so that way we get a better picture how AlwaysON works. Let's just start SQL Server Management Studio. Since we are configuring AlwaysON from DB1, so I'm going to connect it. That's where we created the shared folder. And database, as you can see, test DB is there. If we go to AlwaysON, expand it, and right click and say that new AlwaysON group wizard, click next, and we want to give it a name. So let's check first what are the names would be. I'm gonna open the file, and in this file, enable AlwaysON, you can see for AlwaysON server IP, for cluster, we use 21. Here we are using 31 for both the subnets. And host names are having the IP of 11, 12, and 13. So they are not contradicting. So that way you need the free IPs at this point. If you do a ping, they should be not pointing to anything, and the spawn should fail. And that's the goal, when you're running these commands, when you're creating a cluster always on, make sure that the ping is working, index, all three nodes can talk to each other, and that's the basic. So this is the cluster name we want to give. This is the availability group name we want to create. Cluster name we already created. And now this is the listener we want to create. So I'm just gonna copy these 4 lines, take it to the app server, put it there. Okay, so let's copy the availability group name. Let's put it there, click next. Test DB, see full backup is required. So this is the warning I was talking about. So go back. So we're going to collect the backups. Let's run it. And we created the backups. At this point, always on share filter has all the backup. Let's go back to always on setup. And if I just refresh it, we can see meet prerequisites. So select the test DB, click next. Here we want to add all the 3 replicas. So let's add DB2. Also, what we want is they should automatic failover between each other. So they change automatically to synchronous commit. If you want, we can make DB2 as, say, for example, read-only secondary replica if you want. But that adds the licensing cost. If you're using it for read-only, then you have to pay for license. So make sure that you're only using it if you really need it. So at this point, primary and secondary will be configured as a synchronous commit, and we'll add DB3, which is running on the different data center on a different subnet, which will be basically running on asynchronous commit. And with that, our setup is ready. At this point, you're only paying license for the primary node, and that's one of the best setups you can do. Now we are configuring with the replicas. Now we want to set up the listener as well, to which applications will be connected. So our listener name, as we have it here, will be LW19. Some naming convention is always good. This is the port number, and when you click here, you can see IPv addresses there. So first shows up, and there are 2 networks, so you can see both are there. We already decided 31 is a free IP address available for this network, so we'll use that. And I'll be adding the second one, which is 31. Click OK. So we added both the network. Go next. The other settings you can configure, like backup preference. This is not the goal of this video, or if you want to do read-only routing, that all you can do. We're good for now. So this automatic seeding option will automatically create the databases on all the replicas, restore them, and basically set up the whole always on. This is super simple. We are using the latest version of SQL Server Management Studio, and even if you are using older version of SQL Server, this is where it works really well. So click next, and everything is validated. Click next. We're ready to configure. You can validate your configuration. You can script it out if you want. Click next, finish. So at this point, always on multi-subnet cluster is getting created. As you can see, it took like a couple of minutes for setup to be done. If I click close, you can see W19 primary is there. If you expand, you can see there are 3 nodes are there. DB1 is primary. You can see database is test DB, as well as our listener is ready. So at this point, you can connect using the listener. So if rather than connecting database, I can just put the listener and connect, and voila, the database is there. Test, it's synchronizing. If you go to always on and right click, and you can say show dashboard. Here it's showing us that all the 3 nodes are there working, and everything is green. So you can see all test database on every node is synchronized. So it's synchronized, no data loss because this is synchronized. Third one is synchronizing because it's asynchronous, so it may have some data load, and that's why it's the third node. The reason the third node we are keeping asynchronous is because they are running between different data centers, and typically the latency is pretty high between different data centers. So now within the data center, these 2 nodes are basically close to each other, but this one is different data center. That's why it's not a good idea to keep them separate, because the latency would be pretty high. Here, every transaction you're commenting on DB1 or DB2, whoever is primary, at any point of time, it has to go and commit the transaction on the second node. When I say commit, it's basically committing at the log level, not actually in the database level, which is fine because log can be read and the transaction can be applied. That way, secondary will always be able to take over primary role whenever it's needed. Okay. So at this point, we configured it. Now there are a couple of things we want to configure. So I'm going to go back to our main screen, close enable always on. Let's open the second script, post always on config. So we are setting some cluster parameters to avoid the duplicate IPs. So what happens is that when we are creating this listener, it's basically two IPs are in different subnets. So basically domain controller will have two different IPs at any point of time available to it. We don't want it. We want to set it to use only the IP which is currently available. Whenever we do this lookup or ping, that's what we want it to be returned. So first, let's get the cluster resource name. So run it. So I can see that the cluster resource name is this. This is the cluster resource we want. Let me run this command so you can see. We are saying that this is AW19. This is our availability group name, and LW19 is our listener name. It's online. Owner group is availability group, and then it's a network name resource. So for this resource, we want to get the cluster resource parameters. So we can see there are two values which I care. First is host record TTL. This is set to 1200, which is 20 minutes. I typically like to set it to 60. It depends on your setup. You can change it for this test environment. And this is the setting I was talking about. Register all provider IPs. We just want only the one which is currently active. So these two settings we want to change. Now the next command, as you can see, will do that. So these two will change the settings, but they'll not be affected. So we need to run the third command which says update cluster network resource. This will do it. And now we can check what are the values we have. And we can see the value is 60. Now you can see the value is 60 and 0. Good. So now another setting which you might want to change is the least timeout setting, right? So if I look at the current value of least timeout, so we populate it to the variable. Let me run it. You can see this is there. So let's see the current value. It's 20,000. We're changing it to 30,000. This just to reduce the number of timeout errors false timeout errors we may remove. I noticed that for multi-subnet clusters, we are finding 30,000 is a better value, and your environment may very well be different. So this is a test environment. So I'm showing you what changes you can do. So now value is changed. Now there's one more thing, which is what we call update subnet delays. So by default, subnet is 1020 threshold, and then for the cross subnet and same subnet is 1030. I typically, for the same subnet, I'm okay, but I change the threshold to 30. It's completely up to your environment. But for cross subnet, I definitely don't want to get too much error, so we want to change it to 2000. So that just reduces some of the false alerts you might see because of, typical temporary network issues or something. Once we are done, we can check the values are changed to 1000, 100, 1030. So that's excellent. Now, after all the setting is done, what we want is we want to collect to the cluster. We have all the resources here. So this resource, we want to restart it. So what we are doing is stopping the cluster resource and starting it again. So at this point, SQL Server is configured with always on. So before we go, let's quickly go to the app server and then validate that failover cluster service is able to see always on. This is important from conceptual point of view. This will help you understand how creating this object changes the way we configure the cluster first. So make sure that when you configure the cluster, plain cluster, there was nothing in the roles section, and now you can see AW19 is there in the role section. It's a start, and at this point, Windows 19 is up and running. I'm not sure why it is start, so let's start the role. For some reason, it was stopped, probably because we restarted the services, so just do that. So at this point, it's all good. Everything is green. And you can see 20 is not the IP. This is the deactivated IP. So at this point, if you do ping to LW90, you'll be able to see that it will connect to the current AlwaysON server. And you can see 10, 10, and 31 is there. When we do the failover, it will still be 10, 10, 10, 31 because it's in the same data center. So both VMs. So all basically what SQL Server is doing is that this particular LW19 has a DNS entry. In that DNS entry, it's changing between these two. If it's in the first data center, you'll always get NS lookup value to this. If it's in the second data center, you'll be getting this value. Now, when you're switching between data center, you'll see some time it takes to propagate the changes, and that's something we'll cover in the next video. With that, I believe we have completed configuring the SQL Server 2019 Multi-Subnet AlwaysON cluster on a test Hyper-V machine which is running on your laptop. That will be the end of the session, and at this point, I will upload the scripts for the part 2 where we go ahead and did all the testing. And if you guys want it, let me know. We'll create another video to retest this setup. The setup video second is exactly doing that activity where we do multiple failover testing exactly for this setup which we created today. With that, thank you very much for joining me on this tutorial and staying with me. I really appreciate you spending your time with me. Thank you, and talk to you later. Oh, and don't forget to subscribe and like.